In today's lecture, I'm going to talk about introduction on DC fundamental. So these are the basic components on DC circuit. So we could have capacitor. This is a resistor. And this is like a series circuit. This is also another series circuit. This is a parallel circuit. And these two are the kind of like multimeter. These are what we use to measure the either resistance, current, or the voltage. This is a breadboard. This is battery. So these are the basic application for the basic circuits. So this is like series circuit. We have the power source, then power on the light. This is the Ohm's law. So this is another application we use as an amplifier. So we have a sound through our microphone, and after the amplifier, it can turn up our voice. For this one, application 3 is a temperature monitor. Skills, tools, basics on electrical engineering. So tools, we have multimeter, breadboard, wire stripper, or cutters. We use it to cut the wire. Problem solving skills, we need math, deduction, and memorization. Let's look at SI system and units. The metric system is an internationally adopted decimal system of measurement. It is in widespread use, and where it is used, it's only or most common system of weights and measurements. It's now known as the International System of Units, which is SI. It is used to measure everyday things such as mass of the sack of flour, the height of a person, the speed of a car, and the volume of fuel in its tank. It's also used in science, industry, and trade. So we have prefix here like kilo, hecto, deca, deci, centi, milli, something like that, a different unit. And we convert to like 1,000, 110, 1/10, 100s. SI system and units. So we have quantity, we have length, mass, time, electrical current, temperature. So for the length, we use symbol L. For the mass, we use M. And the unit for the mass is kilogram, which the symbol is kg. For time, we use T. And the unit is seconds, and the symbol is S. So let's say T equal 2 seconds. We have the current I. Unit is ampere. The symbol is amps. So let's say I equals 2 amps. We also have the temperature. It's Kelvin. It's a K. Sometimes we also use Celsius degree. So there are another table about the quantity, symbol, and a unit. So we have force, energy, power, voltage, charge, resistance, capacitance, inductance, frequency, magnetic flux density. So when we have length, this is what we have the unit. In order to convert to something else, we need the converter here. So if we have inch here, we need to multiply by this number in order to get a meter. So let's say if we have 1 inch, we equals 0.0254 times meters. So that's how we use this. So when we have this, we need to multiply by the converter here in order to get different units. That's how we convert the unit. So converting between matrix prefix. So we have 1 kilometer, how much meters there? So it will be 1,000 meter. And the backward 0.001 kilometer, that will be 0.001 times 1,000 meter, which is 1 meter. And 1 centimeter, how do we convert it to meter? So we need divided by 100, so it will be 1. Basically, when we write, it will be something like this, 1 over 100. Same thing, 100 centimeter equals 100 centimeter times 100 centimeter. So that 100 centimeter, that's 1 meter on the top. So that will give us 1 meter here. 1 milliliter is how much liter here. So the converter is 1,000. So 1 liter equals 1,000 milliliter. So that would be 1 over 1,000 liter. 100 milliliter will be 1 liter. Converting between matrix prefix. So 1 kilometer equals 1,000 meters equal 10 to the 3 meters. So 0.001 kilometer equals 1 meter. 1 centimeter is 10 to minus 2 meter, which is 1 over 100. 100 centimeter is 1 meter. 1 milliliter is 10 to the minus 3 liter. And 1,000 milliliter is 1 liter. 1,000 milliliter is 1 liter. The power of the 10 notation used to express very large numbers and very small numbers. So let's say if we have something like this, we can write into the 10 to the power notation. And also if we have very small number 0.000000123 we can also write it in the power of 10 notation. It's made of base and the exponent. So this is a base 10 and the exponent something. Example, let's say a equals 247 followed by 3 zeros. So the decimal is here. Every time we move the decimal to the left, we can add 1 to the exponent. So 1, 2, 3, 4, 5. So we move the decimal 5 times from the right to left. So that will give us 10 to the 5. So 2.47 times 10 to the 5. And b equals 0.000568. So the decimal is here. 1, 2, 3, 4. So we just need to move it 4 times in order to get us 5.68. That's why we get negative 4, because we move the decimal from the left to right 4 times. Multiplication. To multiply numbers in power of 10, multiply base numbers, add exponent. So this is the base number, 2.5 and 3, these are the base number. So this is how we do the power of 10 multiplication. We multiply by the base number, then add exponent. So what we do is 2.5 times 3 multiplied by the base and add exponent times 5 plus 2. So that's how we get 7.5 and 10 to the 7. Same thing on this one, so 2.5 times 3. And this one's 10 to the 5 minus 2. That will give us 3. So we get 7.5 times 10 to the 3. And for this example, we read 2.5 times 3. Then we add exponent. Since they are negative numbers, so 10 to the minus 5 minus 2. So that will give us 7.5 times 10 to the minus 7. Division. To divide numbers in power of 10, divide by the base number and subtract the exponent. So here we need to do the divide base numbers, 7.5 divided by 3, then subtract the exponent, so it will be 10 to the 5 minus 2. This one, 7.5 divided by 3, which is 2.5, then 10 to the 5 minus -2, so it will give us 10 to the 5 plus 2, because minus will be plus, so it's 10 to the 5 plus 2, which is 10 to the 7. On this one, it's 7.5 divided by 3 times 10 to the minus 5 minus 2. So minus will give us plus, so it's 10 to the minus 5 plus 2, which is 10 to the minus 3. And the base is 2.5. So this is the answer for us. Addition and subtraction. Addition and subtraction here. So we need to adjust all the number to the same power of 10, then perform the addition or subtraction. Keep the power the same. So here we need to adjust them to the same power of 10. So we have 10 to the 3 here, 10 to the 2 here. So we need to make them the same power. If we increase the power here, we need to move the decimal number to the right. So we change it here from 3 to 0.3. That will then change the 10 to the 2 to 10 to the 3. Then we just add the base. So 2.5 plus 0.3, which is 2.8. Then keep the power the same. So times 10 to the 3. For subtraction, same thing. We also need to change that to the same power. So we change the 10 to the 2 to 10 to the 3. Then adjust the base number. Then we do the subtraction, 2.5 minus 0.3. Then keep the power the same, 10 to the 3. For the power, raising a number to the power. So example, 2 times 10 to the 3 power 2. That will give us 2 to the 2 times 10 to the 3 to the 2. That will give us 4 times 10 to the 3 plus 3. So it's 4 times 10 to the 6. Same thing here. That's the same example. So that's the result that we get. For the roots, so that's 4 power to the half. So that basically square root 4. That will give us 2. For engineering notation, the power of 10 must always be a power of 3. So it's something like this. So we have minus 9, minus 6, minus 3, 3, 9, 6, 9. So it's multiple of 3. Sometimes E is used instead of the base of 10. For example, 5 times 10 to the 6, so we write 5e6. 10 times 10 to the e to the minus 6, we write 5e minus 6. So this is kind of engineering So this is kind of engineer notation. So they have power 10s, power to 12, power to 9, 6, 3, minus 6, minus 9, minus 12. Then we have the prefix carrier, giga, mega, kilo, milli, micro, nano, pico. These are simple for this prefix. And for the base number is between 0 to 999. That's the base number for the engineer notation, times 10 to the power of multiple of 3s, something times 3. This is the one example. This is the example for engineer notation. So 10 to 3 meter, we can convert it to 1 kilometer. 5 times 10 to the minus 3 meter is a 5 millimeter. And 0.5 times 10 to 3 gram is a 0.5 kilogram. 5 times 10 to the minus 6 meter is 5 micrometer. And also we have scientific notation. It's more general use than the engineering form. Engineering notation is a subform of the scientific notation. You can have any power of 10 in scientific notation. The base is always a value greater than 0 to less than none. So if we have a number here, we can just separate them. So we have 7 digits. So we can have 60. If we move the decimal here from right to left, 1, 2, 3, 4, 5, 6. That's how we get 10 to the 6. So 6.71 times 10 to the 6. For this one, we need to move the decimal from right to left, same thing. 1, 2, 3, 4, 5. You need to move it 5 times. That's how we get 10 to the 5. But for the engineer notation, it's 10 to the multiple of 3s. So 5 is close to 3. We can also convert that to 6. But that number will be 0.8505. 0.805 times 10 to the 6. That's how we convert the large numbers or very small numbers to scientific notation or engineer notation. Alright, this is everything for this lecture. Thank you for watching.